5G standards and spectrum. 5G standards paved the way for major advancements in the field of communications for areas as diverse as industrial automation, telemedicine, self-driving cars, and augmented reality. The importance of standards. Imagine bringing together a whole industry to get them to agree on the direction of a technology down to the minute details of implementation. This process is called standardization, and it is critical to industries such as telecommunications which, to be most effective and have the greatest impact, are truly global in scope and application. Standardization in the telecommunications industry has far-reaching economic implications worldwide. But the process also has implications for fundamentally transforming the way communications are facilitated, whether it is voice, data, messages, or media sent between people, machines, and things. The complex process requires consensus between numerous stakeholders across diverse industries on various elements of a given technology to meet the needs of individuals, institutions, and industry now and into the future. As the communications industry transitions from 4G to 5G, technology leadership is vital to bring all the key elements together, including competence, innovation, trust, and perseverance to drive discussions within standards bodies and organizations to define technical specifications. 5G standards. 5G, the next era of mobile networking, expands the network to connect people, machines, objects, and devices. 5G is designed to deliver a variety of capabilities including multi-Gbps peak rates, ultra-low latency, massive capacity, and a more uniform user experience. 5G standardization is the outcome of an exhaustive process. The process includes building consensus around a technical direction among diverse parties such as vendors, operators, and other interested groups researching and developing technical standards based on the consensus technical direction while maximizing technology compatibility, interoperability, security, repeatability, and quality. Intel's role in standards. Coordinating with major operators and vendors, Intel led the efficient and successful introduction of 5G and LTE/5G New Radio, NR, interworking. With a dedicated team of leading communications engineers, Intel continues to spearhead the development of 5G and is committed to 5G standardization and beyond. In a leading role for the development of the 5G ecosystem, Intel participates in well over 300 standards groups worldwide, holding leading positions in various working groups in ITUR, 3GPP, and IEEE, among others. Intel provides proprietary research, reference designs, and insights to make the full potential of 5G a reality. 5G standards bodies. The primary 5G standards making bodies include 3GPP. The third-generation partnership project formulates the 5G technical specifications which ultimately become standards. Release 15 was the first release to define 5G implementations. The release also includes a set ongoing 5G studies to explore the next-generation architecture and 5G NR, focusing on enhanced mobile broadband, ultra-reliability and low latency, frequency ranges, and the importance of forward compatibility in radio and protocol design. IETF. The Internet Engineering Task Force, IETF, partners with 3GPP on the development of 5G and new uses of the technology. Particularly, IETF develops key specifications for various functions enabling IP protocols to support network virtualization. For example, IETF is pioneering service function chaining, SFC, which will link the virtualized components of the 5G architecture, such as the base station, serving gateway, and packet data gateway, into a single path. This will permit the dynamic creation and linkage of virtual network functions, VNFs. ITU. Based in Geneva, the International Telecommunication Union is the United Nations specialized agency focused on information and communication technologies. ITU World Radio Communication Conferences revise the international treaty governing the use of the radio frequency spectrum and the geostationary and non-geostationary satellite orbits. The spectrum factor. Spectrum, the radio frequencies used by mobile wireless communications, are the most vital and important resource for mobile technology, enabling enormous societal and economic value. Without spectrum, mobile communications are essentially not possible. Spectrum, however, is a finite resource. As such, regulators around the world must determine how to allocate this precious resource for various needs in the most optimal manner. With multiple and often competing national interests at play, international spectrum policy and management is a complex process involving organizations such as the ITU or regional regulatory groups, regulators of various nations, and commercial stakeholders such as service providers and vendors. Regulators in each country basically determine which spectrum bands will be made available for mobile communication technologies. 5G spectrum. 5G spectrum refers to the radio frequencies that carry data between user equipment, UE, and cellular base stations to the data's endpoint. 5G spectrum includes low-band, mid-band, and high-band frequency ranges. In addition to sub-6 GHz frequencies that have been utilized by previous generations of mobile wireless technologies, 5G can also utilize higher frequency ranges starting at 24.25 GHz. These higher frequency ranges have the potential for much wider channel bandwidth. The wider the bandwidth, the more data that can be transferred. This allows more devices to operate concurrently, decreases latency between sending and receiving data, and delivers data at a faster rate. Intel's role in spectrum. Intel's experts play important roles in helping to shape spectrum policy for current and future generations of mobile technology development. Intel often plays a leadership role in identifying opportunities to facilitate various wireless technology use cases and engaging with governments around the world on spectrum policy advocacy, including providing input on important technical requirements. Intel also engages with industry groups like the GSMA, CTIA, GSA, and Wi-Fi Alliance to ensure there is adequate spectrum to fulfill the potential of 5G.